Hi, Mark. Welcome to the Power Talk Show powered by Business Talks Weekly. Thank you for accepting our invitation and joining us today. Before we start a conversation, can we run through your professional background and what led to the creation of Answer Robotics?
Sure. So I'll give you a little bit of a background on myself. Goes pretty far back, actually. I built my first robot when I was 14, and I'm far older than 14 now. I did, after university, I started in medical product development for Hewlett Packard, Philips, Pharmacia, Becton Dickinson, a bunch of really well-known medical device companies working under the jurisdiction of the US FDA. So there was a lot of good process to learn in that case. Somewhere around 14 years ago, I joined a small company called Kiva Robotics near Boston. And Kiva was working on an AGV for warehouse automation. And they had, or not they, the founder, Mick Mounts, had a really novel idea, which was born from his prior startup experience where he found that humans are really good at one thing but not another. And in this case, in the warehouse, he found that humans are really good at picking an item off of a shelf but not good at much else. And a quick way to convey that is when you go to the grocery store, it takes a half a second to pick something off of a shelf, but it takes you 5 minutes to go find that thing or get to where it is. So you're good at picking it off the shelf, but you're not very efficient about getting to the shelf. So his idea was to invert the warehouse, and instead of the human walking, 20 miles per day, pushing a cart, picking things off of the shelf, of which the actual useful time that you need a human was like 1%. He decided that it would be smarter to have the robots bring the shelves to the human and just have lots of robots bringing lots of small shelves to the human and keep the human for what we couldn't do with robots, which is pick the item. That's been an elusive goal for the last 15 years, which is picking the item by by a robot. Human is still generally more effective at that than a robot, but everything else turns out the robot is much better. And he had this idea, and actually it turned out that that idea was a good idea, and other people thought that was a good idea. And that's evidenced by the fact that his idea spawned essentially a whole industry of AGV robots in the warehouse. And it was further validated by the fact that Amazon bought Kiva for $750 million, which, today that kind of money falls out of Elon Musk's pocket. But 15 years ago, that was a lot of money. And everybody else who knew anything about robotics saw that money and said, oh, we have to try that too. And that kicked off a whole industry. So it's been a very interesting journey in product development, robotics, and management. And I've gone from essentially a technician, put myself through school selling tires, went on to become a technician, then had my first, when I graduated school, started in engineering, went through systems engineering, product engineering, mechanical engineering, and also then went on to program management and sales and quite a bit in supply chain and manufacturing. I would say that's the first half. And then the second half was really deep into everything AGV robotics. And then AGV robotics then started to spread off into AMR. And for your listeners who may not understand the difference between AGV and AMR, when it comes to robotics, especially in the warehouse or the factory, we can think of it pretty easily. An AGV is autonomous in the sense that it can follow a line. So you may have this thing follow a line in the factory and just carry something from point A to point B and back along this line all day. But modern AGVs use, instead of a continuous line, which could be a magnetic stripe or paint, they can interpolate a line. So you just have dots. Consider it a dotted line. And in most cases, those dots are QR codes that are glued to the floor or stickers on the floor about a meter apart, because that's about the accuracy you can trust the robot to navigate on its own. So if something interrupts that line, like a person stands on that line or some garbage or whatever interrupts that line, the AGV cannot navigate by itself. It just stops until you clear that line. We can contrast that with AMR, which have been undergoing a genesis. And AMR don't use the line. They instead, when you think about the line, you're looking down at the floor to find that line. But with that in AGV, in AMR, you're looking ahead of you, similar to the way a human might look. When you walk from point A to point B, you're not looking at the floor, at least you shouldn't be, because you're going to hit something. Instead, you're looking ahead of you and you're looking at the natural landscape, and you can use your brain to figure out how to get where you want to go. AMR is pretty similar. AMR is using a map similar to the way you might create a map in your mind. We create a map with LiDAR. We make a 3D map of your space or a 2D slice map. And then the AMR has sensors that can recognize. Now, those sensors could be cameras or LiDAR or a hybrid or sensor fusion version of those. And when you consider AGV can be millimeter precision. So they're very precise in their navigation, where AMR is more like centimeter precision. It's still precise, but not quite as precise. But AMR has the advantage that it has a map. And on this map, it has free latitude to navigate within that map instead of having to stick to the line that AMR has to stick to. So you've got a lot more flexibility with AMR. Now, these two things have very kind of unique applications. A great example would be a warehouse where you want to store material. The real estate in the warehouse is quite expensive, so you want the material storage to be very dense. So the robot should be very precise so that you can store the material more densely. If the robot is sloppy, it's going to have collisions, so you won't have high density. But if the robot is precise, you can have high density. AGV wins. However, in the factory space, there generally tends to be a lot of space in a factory. You've got a lot of dead volume. You've got machines and you've got inventory and you've got people manipulating those things. But there's a lot of space for people to walk around or robots to navigate. So AMR wins in the factory because maybe it's not quite as precise, but it can navigate like a person would. If something blocks its way, it can find another path, including turning around and finding a completely different route, because in its brain, for lack of a better term, it has this map and it knows where it can go and where it can't go and how to get there. So AMR wins. The other part of your question was, how did Answer come about?
Yeah.
Well, that's a good question because Answer is 5 years old and I've been with Answer for a year. Well, not a year, since February, early February. Answer is an Indian-based company. However, I operate Answer in the US and also in parts of APAC. So, before they would bring somebody in like me to help them run outside of India, the company would need to have a mature product because the US market tends to be a high margin market with a lot of opportunities, but it's also incredibly unforgiving. So it's a wise choice before you try to go after the gravy in the US market. You better make sure your product is pretty well dialed in and that your company is robust so that you can react to what the struggles you're going to face as you enter these new markets, which means you have to have funding because it's not going to be cheap. And you have to have some pretty smart people because it's like I said, unforgiving market. If you make a mistake, there's very little sense of humor about that. Whereas it seems to me that in India and other parts of the world, the clients and customers tend to be a lot more forgiving about schedules and timelines and performance and all of this. Where in the US, if you say your robot can do something and it's going to be installed in this much time and cost this much money, if there's any deviation, the deal will probably end regardless of how far along it is. Consider it a late term abortion. So that's a little bit about me, a little bit about Answer. I'll add that Answer is not my first time doing this. I've since Kiva, which became Amazon Robotics, which nowadays, Amazon Robotics, the robots that we started with in 2012, the volumes were pretty modest. Let's say before Amazon started talking to us, it was in the low double digits, maybe triple digits per year. And the company would struggle mightily because we have many different customers and not enough people to satisfy all the customization. Because at that time, we ourselves were still learning what we could do with this technology we developed. When Kiva came along and acquired I'm sorry, when Amazon came along and was acquired Kiva, sorry, suddenly we no longer had these commercial customers, much to their chagrin. They were quite upset because they had invested. As a matter of fact, one of our customers went on to invent his own robot company and is now quite competitive. However, Amazon went on to leverage Kiva to become the behemoth that it is today. As a matter of fact, I would go as far as to say as Amazon couldn't deliver the service it delivers today if it hadn't introduced robots to its operations. Now, I could say Kiva, but could have been anybody, but they picked Kiva smartly because we fit exactly what they needed to do. And when we single threaded just on Amazon operations, the beauty of Amazon is highly reproducible. If they have 100 warehouses, they're all almost the same. Every fulfillment center, if you woke up in one, you wouldn't know which one you woke up in. So they're designed for scale, and that's where Amazon worked really well with Kiva. Post Amazon, I went on to lead a Chinese competitor and then another Indian company, which was not only, I wouldn't say necessarily competing, but in an adjacent space. And they were more of a end-to-end robot provider, not just AGVs or AMRs, but ASRS, all sorts of things to the warehouse. And then now I'm leading Answer, and with Answer, we're fundamentally different in the idea that the founders are young and they're roboticists at heart. So they really think from the technology perspective as opposed to other perspectives, which is a bit different from most cases, or at least the other cases that I've dealt with. And that brings us to where we are today, which is the new technology that we're introducing. Answer has three new products that we can talk, well, that I can know about, one of which I can talk with you about because it's public knowledge, and that would be our hybrid robots, which if you remember, I was talking to you about AMR and AGV, and with
Yes.
hybrid robots, we combine the two. So we have the unique ability to do something where we can navigate freely around a warehouse or a factory using AMR mode. But then if we need to do a task that requires higher precision, we can switch over to an AGV mode. So we have all of these modalities, which gives us a lot of value or gives our clients a lot of value from choosing us because we're much easier to integrate. We're faster to stand up in their warehouse. And also, if their business changes, their investment in their robotics doesn't just evaporate. We can very easily adapt with very little overhead to do that. So it gives our end users, our customers, an extra level of safety, not only in the human aspect, but in the business aspect. So that's a little bit about myself,
Uh,
Answer, and the technology and where we are today.
what are the challenges the current industry faces right now in the world of robotics?
Well, in the world of robotics, you have to look at the trajectory we've been on. We started off with AGVs many, many, many years ago, probably 40 years ago, but they were not very useful. They were they had a very small corner case you could use them for. You may remember like Toyota and Japanese companies were big on using these AGVs. They would just literally follow a line. So if you needed to, bring tools to a workstation, or you needed to bring screws or instructions to a workstation for a particular worker, you just put it on the AGV and eventually it would get to the worker and he might wait for that stuff to arrive. So it's very primitive. And that stayed that way for all those years until 2012 with Kiva with AGVs. Proved their value, and instead of building double or triple digit robots per year has now built, from what I understand, close to 1 million of those robots. So they are quite useful and they've really spawned an industry. So Amazon, by orders of magnitude, leads in volume. And by the way, they don't sell those robots. They only use them within Amazon. But it has spawned an industry where competitors might build, a great year for them might be 3 or 5,000 robots per year. That would be a fantastic year for most players for AGVs. And AMRs will be lower volume because they have not yet reached much adoption, at least in the greenfield warehouse space. But AMRs are the newer technology. And now you ask, what technology hurdles do we face? The technology hurdles tend to be on two aspects. Number one is business. Every warehouse operator would love to have automation because getting humans to work in a warehouse is, costly and difficult. People don't like to work in a warehouse anymore. The more educated your population is, the less they want to work in a warehouse where it requires no brains. They want something that's a bit more challenging. Whether it makes more money or not is almost irrelevant. They just like to be challenged. You have some people who went to school to get a degree. They don't want to work in a warehouse. They want to do something that leverages their brain or their degree. So, having a glut of educated people in your country means that it's harder to get people to work in mundane jobs. So, the challenge is we've got a shortage of people. However, for most companies, the investment and the interruption and the risk associated with putting automation in, it's not really worth it. If you've got a brand new if you're a big company and you've got a brand new warehouse, let's say you've got a warehouse of 100,000 square meters, you want to design that around automation because that's a big investment, hundreds of millions of dollars. But if you're let's say that all of those players, they've already gone automation in the last 10 years. So now the playing field is no longer the low-hanging fruit of those big operators. Now the playing field that all of us robot providers are competing in is smaller warehouses where you have a smaller company. They have a small warehouse, maybe 1,000 square meters or 10,000 square meters. It's not as huge as it used to be. They don't have the money to invest in a new warehouse. They want to keep their old warehouse and they don't want to interrupt the operations to take those operations down for, at best 3 months, at worst 8 months. It's very disruptive for their business. It's very capital intensive. So the new challenge is finding a solution where these SMEs have the bandwidth, both financially and business opportunity, as well as mindset wise, to acquire this kind of a technology. And more, the more difficult it is to have labor or find labor and retain labor, the more and more the focus is there and less on the CapEx, the capital acquisition costs.
Understood. So you talked about automation and scale. So what does automation at scale mean to
Automation
you?
and scale. Oh, it's scale.
Yeah.
Well, automation at scale there's different facets to that term. Automation at scale could mean you're a big company and you have, 1,000 warehouses. Now, only Amazon approaches that type of scale. They've got hundreds of warehouses that are each 100,000 square meters. It's giant, their footprint. That's, if you're going to automate an Amazon across its network, that's automation at scale. They might need 1 million robots, which they have. And then on the other side of that coin, automation at scale is you have 1,000 SMEs who have only one warehouse each or two. How do you automate them? It's the math is the same, but the difficulty and the complexity and the uniqueness of each case is exponentially more difficult. So how do you scale into that type of a market that's more difficult?
Understood. So how do you view, Mark, ethical responsibilities when, deploying an autonomous system?
Well, as I've been in the industry and I've been on both sides of the coin, right? Or I've been on all different sides of the table. I've been the designer, I've been the provider, I've been the customer, and I've had to deal with the maintenance and operation of these systems. So, from an ethical perspective, I approach this business, and one of the reasons that I stay in this business is because I've worked hard to cultivate relationships and cultivate businesses that are very sort of transparent. I'm not very opaque, and neither are my operations. We tend to be very transparent. And when it comes to robotics, there's a lot of companies that will, advertise many things. The biggest things that they advertise are the capabilities of the system, which is they tend to stress hardware when they should stress software. They also tend to make a lot of statements about how quickly they can deploy and about how reliable the system is and how much the system will cost. Now, cost is not just the first year cost or the cost to get it running. There are other costs. And so, when I think about transparency, I want to be clear about the realities of the system. When my operations and Answer in specific talk about the robot capabilities, we don't want to overstate the hardware capabilities. We don't want to overstate the software capabilities. As a matter of fact, I would rather under promise and over deliver anytime. If I can underpromise and overdeliver, that equation usually equals a smiley face. And that's what we target. And the same thing when it comes to our deployment costs and our deployment, especially timeline. It's very easy to say, oh, I would say not everybody, but many people, too many people in the industry will say, if you put an order in today, if you sign here and you put your first 30% down, this thing will be up and running in 90 days. And I can tell you 99.9% of the time that never happens. And I think that that's entirely misleading and unethical because anybody who's been in the space, even for a short time, knows these are complex systems and integration. Even if you know your product very well, you don't know your customer's end very well. And there's always surprises. You have to know the systems and the people, both, not just the systems, but the people on the other side of the table, on the customer side, before you can make any kind of a commitment. And that requires a lot of due diligence. And when somebody doesn't deliver on schedule, whatever that schedule may be, it's very disruptive for the customer because they are saying, okay, they're operating their business and they're saying, okay, we're going to take X days time out because this and this and this need to happen. And then we're going to be back online. So our customers, we can make them aware, we can plan, we can have some schedule mitigation that we keep everybody happy. And if you knowingly or even inadvertently interrupt that or cause a deviation, you're doing a great disservice to everybody involved, including yourself. And then on the other piece, the third leg of the stool is the cost. Now, if there's a delay in a deployment, it's going to cost. It's going to cost somebody because to have people in the facility doing installation, this costs money. These are expensive people. They stay in hotels and they eat expensive food, blah, 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 right? So again, planning and experience matter, but that's only one small piece of the cost. The bigger piece of the cost to consider is something that we always, I would say alumni of Kiva learned from Amazon, which is the 10-year cost of ownership model. And so we and me take that very seriously. What is it going to cost to sustain this system for 10 years? Now, maybe later we can talk about how long should a system last and how long do we last, Anscer. But I would say somebody who, this kind of an investment and this kind of a technology, it should be reasonable to expect it's going to last for 10 years, operate reliably for 10 years before you would think about upgrading it or changing it to a new technology.
So one final question, Mark. What do you think is the biggest misconception about robotics industry in the current market?
That's a broad question. Depends on the type of robot. We have humanoid and we have AGV and AMR, which are really useful for warehouse and factory. I think the big misconceptions lie around, what is possible and what are the realities that I should expect when I really put this system in. Like, let's say I pick a system, pick a company, deploy it, and 1 year later, how many of the things that I was promised or that I expected are actually materialized? And that's where it takes a great degree of education. And if I was on the customer side and let's say I was a VP and I had to sign off on this capital expenditure to buy this system, I would want to make sure that not only that I reasonably trust the vendor, which is always at arm's length, but the person on my side of the table, maybe the director of operations or somebody in this type of a role, really like had some at least 3 years experience with these types of systems. Yeah. As far as like misconceptions, I don't think there's a huge amount of misconceptions. Not as many as misrepresentations. Let's put it that way.
Thank you, Mark, for joining us today on our podcast today. Thank you so much. It's been a wonderful
Yeah, thank you so
conversation.
much, Evan. It's a pleasure to chat, and I hope that your audience finds this somewhat interesting. Have a good day.